Assalamualaikum and good morning everyone. We are from group 2 and today we will be presenting about pre-stress loss in pre-stress concrete. My name is Nur Afika Binti Muhammad Azili and I will start by giving a brief introduction about our topic. Let's start with what pre-stress loss means. Pre-stress loss is the reduction in the initial pre-stressing force that occurs after the force is applied to the concrete member. In other words, the pre-stress that we first applied doesn't stay fully the same over time. Some of it is lost. These losses can happen due to immediate factors such as elastic shortening or time-dependent factors such as creep, shrinkage, and relaxation of steel. Next, I will explain about elastic shortening, which is one of the immediate losses in pre-stressed concrete. When we apply pre-stress to a concrete member, the concrete becomes compressed. Because of this compression, the concrete shortens slightly. We call this elastic shortening. Since the steel tendons are attached to the concrete, they also shortens together with it. This shortening of both materials causes a loss of pre-stress in the tendons. In pre-tension concrete, this happens right after the pre-stress is transferred to the concrete, so the loss occurs immediately. However, in post-tension concrete, if all cables are tensioned at the same time, there is no loss from elastic shortening. But if the cables are stressed one by one, the earlier cable will lose some stress when the later ones are tensioned because the concrete shortens again. In simple terms, elastic shortening means that as the concrete shortens under compression, the tendon also shortens. It results in a small reduction of the pre-stress force.
Hello, hi, my name is SHARBRIENA and I will explain for the friction. So, what is friction? Friction is one of the short-term losses that occur in post-tension concrete where the tendons are pulled after the concrete harden. As they slide through the duct, friction between the tendon and the duct walls will reduce the force. The further the tendon is from the jacking end, the more the force is lost. Furthermore, there is two types of friction effects. The first one is curvature effect that caused by intentional bend or curve in the tendon profile. Friction will increase with the angle of curvature, which means the more you bend, the more friction will occur. The second one is wobble effect. It caused by unintended deviation or misalignment in the duct. Even in a straight duct or small irregularities will also create the friction.
My name is ELMEEZA and I will explain on the next short-term loss, which is anchorage slip. Anchorage slip happens in post-tension systems only. They are mainly caused by the shortening of concrete, friction between the tendon and duct, anchorage slip when the jack is released, and slight relaxation of the steel. These factors reduce the effective pre-stressing force, lower the stress in the concrete, and can lead to greater deflection or cracking, making the structure less efficient. The shorter the tendon, the greater the percentage of loss. This is the pre-stress loss diagram. In this diagram, the top line indicates the force in the tendon before release, which is the full jacking tension. The bottom line is the force after the wedge slips, while the shaded triangle shows the loss of pre-stress due to slip. The delta P is the loss of force at the anchorage, and the L set is the length over which the slip effect spread, which is usually 1 to 2 meter.
Okay, so now we will moving on to the long-term losses, which is creep. Creep in concrete means slow deformation under long-term stresses. It is affected by load size, water cement ratio, aggregate strength, concrete edge, curing quality, and the last one is environmental condition, which is the humidity of the surrounding. And the next one is the effect of creep. Creep can cause the structural change over the time when the materials are under constant load. Beam may be sagged more, column can be shortened, floor might become uneven due to the differential movement. In pre-stressed concrete, internal forces gradually reduce, and can weakening its performance. These effects are slow but critical for long-term safety and design. Now we will see how creep works using this diagram. In day 1, beam shape remains straight due to low strain. In another next 1 year, the beam shape slightly sagging due to moderate strain. In the next 5 years, the beam shape significant sagging due to high strain. As the creep increase, the pre-stress gradually decreases.
Next, moving on to shrinkage. The definition of shrinkage is the time-dependent shortening of concrete as it dries even when unloaded, which in turn causes a reduction in the initial pre-stressing force in tendons. It is a significant factor in both pre-tensioning and post-tensioning. Factors influencing shrinkage. First, original water content. Higher water content leads to greater shrinkage. Second, aggregate use. Stiffer, denser aggregate reduce shrinkage. Third, effective age at transfer. Stressing concrete earlier results in more shrinkage loss occurring afterward. Last one, effective section thickness. Thicker sections dry slower, affecting the rate shrinkage development. The diagram shown is the relationship between creep and shrinkage. First, time-dependent component. It is one of the two main long-term time-dependent deformations along with creep that occurs after the load is initially applied at time t0. Second, unloaded deformation. Shrinkage is the deformation that the concrete would experience even if it were unloaded. This differentiates it from creep, which only occurs under sustained stress. Third, growth curve. The diagram shows the shrinkage curve beginning at the baseline, or just above the elastic straight line at T0 and rising steadily. This indicates that the shortening of the concrete due to moisture loss accumulates over time. And the last one is asymptotic behavior. The curve continues to rise, but its slope decreases. It flattens out over a long period, showing that the rate of moisture loss and resulting shortening slows down until it reaches its maximum, or ultimate shrinkage strain over many years. Next is relaxation. The definition of relaxation is the reduction in stress with time in the pre-stressing steel while the length is held constant. It is a significant factor in both pre-tensioning and post-tensioning systems. Losses from relaxation are generally in the range of 4% to 10% of the pre-stress force after transfer. Factors influencing relaxation. First, time. The longer the steel is under stress, the greater the loss. Second, initial stress. Higher initial stress closer to the steel's yield point causes greater relaxation. Third, temperature. Elevated temperatures accelerate the relaxation process. Last one is type of steel. Low relaxation steel is manufactured to inherently have a smaller loss than a standard steel. In conclusion, the initial pre-stress force is never permanent. It is reduced by both immediate losses, which is friction, slip, and elastic shortening, and the critical time-dependent losses, which is creep, shrinkage, and relaxation. Accounting for all these factors is mandatory to ensure the remaining effective pre-stress provide the necessary long-term serviceability and safety for the structure.
Thank you.